and hello students. We are going to discuss about the Victor Meyer's test to distinguish between three types of alcohol: primary, secondary, and tertiary alcohols. They can be distinguished from each other by doing this test called Victor Meyer's test. It is one of the important tests, and the steps involved in this test will be: alcohols are first of all converted into the corresponding alkyl iodides by treating them with the alcohols are to be treating them with iodine phosphorus, otherwise by using PI3. Preferentially, iodine phosphorus is most suitable to convert alcohols into alkyl iodides. That will be the first step. And second step, thus formed alkyl iodides are to be converted into nitroalkanes. This is possible by treating those compounds with AgNO2, silver nitrite. And lastly, the nitroalkanes formed are to be treated with nitrous acid having this formula. Instantaneously, nitrous acid is produced by treating sodium nitrite and hydrochloric acid combination. And solution obtained above is to be treated with the alkaline KOH, and we are observing the result. Just by the observation, we can have the color difference in between primary, secondary, and tertiary alcohol. So all the three alcohols, primary type, secondary, and tertiary, on treatment with the following reagents, namely iodine phosphorus, silver nitrite, and nitrous acid, and a final solution is to be treated with the KOH alkaline. And after performing all the steps, we can have different colors. With the help of color difference, we can distinguish between the primary, secondary, and tertiary alcohol. Yes, we are starting with the primary type alcohol. It's a primary alcohol, CH3, CH2OH. And we know that it is ethanol, ethyl alcohol, primary in its nature. First step, this on treatment with phosphorus and iodine, the OH can be replaced by iodine so that we can have CH3, CH2I. The compound formed is called ethyl iodide, also known as iodoethane. After that, successively it is to be treated with silver nitrite having this formula AgNO2, where the electropositive silver can combine with electronegative iodine to form AgI. So after the removal of AgI, this could be the result. We can have CH3, CH2NO2. The compound's name is nitroethane. Nitroethane is formed. Now the nitroethane should be treated with the mixture of NaNO2 and hydrochloric acid that results to the formation of HNO2. It is nothing but our nitrous acid. For the convenience, the nitrous acid is written here HON double bond O. When these two are interacting with each other, what would be the product expected? This is the product mode. You see, in the nitroethane, alpha hydrogens are available. There are two alpha hydrogens. Those two alpha hydrogens are combining with this oxygen to form H2O. At the end, after the removal of H2O, we will be having CH3CNO2. When you remove these two hydrogen, two vacancies are there, two bonds are left, and those two bonds are formed in between the carbon and nitrogen. So this nitrogen from the nitrous acid part is combining with this, and this is becoming nitroxime. It becomes oxime, nitroxime. Thus made nitroxime should be treated with potassium hydroxide successively on treatment with alkaline solution of KOH. This hydrogen is a replaceable hydrogen, acidic hydrogen, that will combine with the OH to form H2O. After the removal of H2O, we can have a final product as follows. It's the product mode. Can have CH3, C double bond, NOK. Already it is bonded with NO2. This potassium salt of the above given compound is red in color. So the red color indicates the presence of primary type alcohol. When will you get this red color? By doing all these steps. Step 1, in which the ethanol is treated with phosphorus iodide. Step 2, in which ethyl iodide is treated with silver nitrite. Step 3, the nitroethane thus obtained should be treated with the nitrous acid. After treatment with the nitrous acid, we are getting the nitroxime due to the removal of H2O. And in the final stage, in the fourth step, the nitroxime obtained should be treated with the KOH, where the H is combining with OH to form H2O. At the end, we are getting the red color. The red color compound clearly indicates the presence of primary type alcohol. So thus primary alcohol is giving one particular color. Likewise, if you take a secondary type alcohol, then what happens? I am writing a secondary alcohol. It is a secondary alcohol, the most suitable example of secondary alcohol. It will be 2-propanol, also called as isopropyl alcohol. It is the compound. Secondary alcohol. It is isopropyl alcohol, also known as propane 2-ol. As usually, it is to be treated with the phosphorus and iodine in step 1, so that the OH can be replaced by I, and we can have a product as follows. It is the product of time, and the compound's name is 2-iodopropane. Secondary type compound is formed, 2-iodopropane. After getting this, it is to be treated with the silver nitrite, AgNO2. We have studied that on treating with silver nitrite, Ag can combine with iodine to form AgI. So that the expected nitro compound will be CH3CHCH3. Here I am writing NO2, nitro compound is made. The compound's name is 2-nitropropane. It is a compound formed, 2-nitropropane. After that, as usually, this is to be treated with the nitrous acid, which comes from the combination of NaNO2 and HCl, that is instantly giving nitrous acid. Here I can write that nitrous acid, HON double bond O. In the previous case, in the case of primary type alcohol, there are two alpha hydrogens available, but here you see this is having only one alpha hydrogen that should combine with this OH to form H2O. Yes, after getting the water molecule, this is the result. We can have a product as follows: CH3, N double bond O, CH3NO2. This compound itself is blue in color. And you need not treat this with KOH because this is not having an acidic hydrogen. Previously, nitroxide was obtained. That hydrogen is replaced by using OH with the help of KOH. Here, there is no such kind of acidic hydrogen and is a pseudo-nitrile, and its IUPAC name is given as follows. There are 3 carbon atoms, so that you can call it as propane, the parental source, and there will be presence of nitroso group in second position, so that you can call it as 2-nitroso, and nitro group is also present at the same second position, so it is 2-nitro, 2-nitroso-propane, and this can have blue color. So that's the biggest difference in between primary and secondary. Primary is giving you red color, but in the same steps, secondary is giving blue color. So that's the greatest difference in between primary and secondary. What happens when you take tertiary type alcohol? We can have a tertiary alcohol, namely tertiary butyl alcohol, and we are going to repeat all the steps for tertiary butyl alcohol. Yes, I am writing CH3, CH3, CH3OH, tertiary butyl alcohol, in which the longest linear chain is containing 3 carbon atoms. So it is propane 2-ol. You see the second position in which the alcoholic group is present, and methyl is also at second position, thus it is called 2-methyl propane 2-ol, also known as tertiary butyl alcohol. When this is treated with the phosphorus and iodine, replacement of OH with the help of iodine, so that we can have a product as follows. The alkyl iodide is merged. The alkyl iodide formed is tertiary butyl iodide. The tertiary butyl iodide, for that IUPAC name, there are 3 carbon in the longest linear chain, so you can call it as propane. Now the methyl group is present in the same second position, so that you can call it as 2-methyl, and iodo is also at the second position, so that you can call it as 2-iodo, 2-methyl propane. That would be the IUPAC name of the compound. After getting this compound 2-iodo, 2-methyl propane, successively this compound, this substance is to be treated with the next step called silver nitrite, AgNO2. As usually, Ag can combine with this, so the resulting compound is given as follows. Here I can write that particular substance CH3C, CH3, CH3, NO2, a nitro compound is formed. Now the next step, it should be treated with the nitrous acid, which comes from the combination of NaNO2 and HCl. But here this compound, it's a tertiary type nitro compound in which 3 carbons are present in the linear chain. Its name is propane, and nitro is present in the second position. Methyl is also present in the second position, so that you can call it as 2-nitro, 2-methyl propane. 2-nitro, 2-methyl propane is the product. But this compound do not react with the nitrous acid. Why? Because there is no alpha hydrogen atom. The reaction do not take place, and no color with the KOH. So the color is not formed here, any type of color. This substance is colorless, so that we can have a difference in between primary, secondary and tertiary type alcohol. For the primary alcohol, we are extending up to KOH. For secondary alcohol, KOH step is not there. 2-nitro-2-nitrosopropane itself is blue in color. In the tertiary alcohol, one more step is missing. It is not reacting with the nitrous acid as it is not containing alpha hydrogen atom. Unfortunately, it's a colorless substance. So that we can have a difference in between primary, secondary and tertiary alcohol. And this is about the Victor Meyer test.